Hi everyone and welcome to week 14 for junior cycle ordinary level. So today we're going to be going through probability. So we're going to be going through a couple of theory-based examples, and then I'm going to be doing a couple of exam questions as well. So the first thing we're going to look at is the fundamental principle of counting. So the fundamental principle of counting refers to counting a total number of possible combinations from a set of groups. For example, suppose a restaurant has two options for starters, soup and salad, and then the four options for mains are beef, chicken, fish and vegetarian. We can work out by hand how many total combinations between the two groups manually. So if we've already been told that there are two options for starters, and then for main we have four options. So we can work out by hand, so you can have soup and beef, soup and chicken, soup and fish, or soup and vegetarian. Or you can have salad and beef, salad and chicken, salad and fish, or salad and vegetarian. So they're the 8 different combinations that you can have. Now we can see that there are 8 options, but we can work this out by noting that there are 2 options for the starter and 4 options for the main. So the total number of possibilities is actually the number of starters, which is 2, multiplied by the number of possibilities for main, which is 4, and 2 by 4 gives you 8. So that's the fundamental principle of counting, and it refers directly to the total number of possible combinations from a set of groups. So the next thing we're going to look at is the likelihood scale. So probability is the mathematics of likelihood, so measuring how certain or uncertain an event is. For example, if you flip a coin, the outcome is not always the same, and the likelihood scale is an informal way of describing events and outcomes in words rather than numbers. So I'm going to just underline that, so it's outcomes in words rather than numbers. Now we have an example to show this. For each of the statements, describe how likely this event is to happen. So draw a likelihood scale to represent this. So the likelihood scale, we have impossible at one end, we have certain at another end, and we have even then in the middle. So the first one there, the sun will rise tomorrow. Now that is a given, that is definitely going to happen. So because of that, we put event A underneath certain, or where certain is on the probability scale, or the likelihood scale, should I say. For B, I roll a standard 6-sided die and get a 7. Well, this is impossible because you can't roll a 7. So because of that, we will put event B beside impossible. So that's never going to happen. For C, I flip a coin and get a head. This event is just as likely as the alternative as getting a tail. So this is an even chance. And because of that, we place C bang slam in the middle. For D, what is the probability? So if it will snow in Dublin Airport next year on December 25th. Now this event is possible, but looking at the weather from previous years, it's unlikely. So we don't place it at impossible, but we place it more so near the impossible. So it's unlikely, so it's closer to impossible than it is to even. E, it will rain somewhere in Ireland next year on December 25th. Now this event is likely given the weather in Ireland. So likely but not guaranteed, we put it closer to certain. So that's event E. So that's the likelihood scale, and it's just, I suppose, a way of representing the probability of a certain event happening in words rather than numbers. Okay, so experiments, outcomes and events. So we will use the example of rolling a standard 6-sided die to define some terminology for probability. So the first term there is the experiment. So the experiment is a roll of the die itself. So the outcomes then are the 6 sides. So you're talking 1, 2, 3, 4, 5, or 6. So you have 6 different outcomes. If you roll a die, you can get the number 1, 2, 3, 4, 5, or 6. Next thing is the sample space. That's the collection of all possible outcomes. So in this case, these are all of the possible outcomes you can get when you roll a die. So the numbers 1, 2, 3, 4, 5, or 6. And then finally, an event. It's a subset of the sample space. So here are some examples of events and the corresponding subset of the sample space. So rolling a 6 is, so that's the subset, is just 6 in brackets. Rolling an even number, the subset is 2, 4 and 6, because they're the only even numbers you can roll in the die. Rolling a number greater than 6. Now, there is no number greater than 6 on a die, so because of that, the subset, there's nothing, so it's called the empty set. Rolling a number less than 7, well, that's going to be the whole sample space because you've got the numbers 1, 2, 3, 4, 5, and 6. So that's a couple of different terms that we use in probabilities. It's important to know what each of those actually mean. So then we're looking at the probability scale. So probability is a mathematical representation of the likelihood scale. For each event, we can come up with a number between 0 and 1 to represent how likely we think that that event is going to occur. A probability of 0 means that the event is impossible, and a probability of 1 means that the event is certain, okay? So if I was to draw the probability scale, I'd put 0 here, and I'd put 1 here. Now 0 would mean that the event is impossible. A 1 would mean that the event is certain. And then, as you can guess, in the middle here, this would be an even chance. So in practical terms, if we repeated an experiment a large number of times, so say n number of times, we can count the number of times a particular event occurs, so f of the frequency. Then the probability is given by f divided by n. For example, suppose we have a coin and our event is getting a heads. If we flip the coin 100 times and we count 53 heads, then the overall probability of getting a heads is 53 out of 100. So if you have 100, if you flip it 100 times, right, flip a coin 100 times and you actually only land on heads 53 times, that's actually the probability. And if you put that into the calculator, you'll get 0.5. If we let h represent the event that a coin is a heads, then the proper way we can write that is the probability of landing on a heads is 0.53. So that's the way we write it correctly. So I've actually some exam questions now. That's the theory done. So we're going to look at paper 2, 2011, question 6. So we'll look at question 6 here. Mary has a bag of marbles and the number of marbles of each colour is shown in the box. So we have 7 yellow marbles, we have 3 green marbles, 4 red marbles and 2 black marbles. So first of all, how many marbles are in the bag? So in order to get that, we add 7 plus 3 plus 4 plus 2. And you can put that straight into the calculator and you will get 16 marbles in total. Mary takes a marble from the bag at random. Complete the sentence below. So the probability that Mary will take a something marble from the bag is 1 out of 4. So a quarter. What accounts for a quarter of the marbles? Well, we have 16 marbles in total. What would we need to take out of 16 in order for it to be a quarter? Well, the answer is actually 4. 4 out of 16 gives us a quarter. Now, which number of marbles gives us 4? So it's going to be red. So the answer there is red. Okay, so then let's go part C. So the probability of taking a red marble is greater than the probability of taking a yellow marble. Is this statement correct? Give a reason for your answer. Now, the answer here is actually no. Now, the reason why is because you actually have more yellow marbles than you do red marbles. So because of that, the probability of taking a red marble is not greater than the probability of taking a yellow marble. So we're going to write that down. So there are more yellow marbles. So there are more yellow marbles than red in the bag. So you've justified it then. So Mary found 5 more black marbles and added them to the bag. Fill in the number of marbles of each colour in the bag after she done this. So for yellow, that doesn't change, that's still going to be 7. For green, that doesn't change, that's going to be 3. For red, that's going to still be 4. Now, we had 2 black marbles. She added 5, so 2 plus 5 is going to give us 7 black marbles. Mary takes a marble from the bag at random. What is the probability that she will take a black marble from the bag? Okay, how many black marbles do we have? We have 7. Now, how many marbles do we have in total this time? So that changes. We need to add up the total amount of marbles that we have. So we're going to add 7 plus 3 plus 4 plus 7. So I'm basically adding all these numbers together. And when I do that, I get 21. So the answer there is 7 out of 21. And that's the answer to that question. I think that's the last question on the paper. So we're going to move now to 2012 paper 2. Okay, so if we look at question 4 here, let A be the set of months in the year, list the elements of A. So literally what you're going to do here is you're going to list all of the months. So you've got January, February, and this is the way you do it. You put it in the set like we see here. So we've March, April, May, June, July, August, September, October, November, and December. So that's it, that's A, which are all of the months of the year. Now, what is the probability that a month chosen at random from set A begins with the letter J? So we need to find how many months begin with J. So we have January, we have June, we have July. So that's only 3. So that's going to be 3 out of 12. Now can we shorten that down? We can. 1 into 3 goes once, 3 into 12 goes 4 times, it's a quarter. So that's that full question done. So we'll go to the next one. The next one is going to be 2017 paper 2. Okay, so Jerry is carrying out a survey on the students in his class. His questions are about the apps and social media that they use. So for part A, write a question that Jerry could use that would give him numerical data. So your question should be about apps or social media. So you need numerical data, which means obviously numbers. So think of a question that Jerry could ask that would give him numerical data. So something like, how many students use Snapchat every day? Something like that. So how many students use Snapchat every day? And you'll be getting a definite figure then, and it's numerical data. So we'll go to part B. Jerry is buying a new phone. He can choose from 3 different memory sizes, so 8, 16 or 32. Each size comes in 3 different colours, black, white or silver. Write the 9 different options that Jerry could choose for his phone into the table below, taking into account memory, size and colour. 2 are already done for you. So if we went with the 8 for the memory sizes, so 8 and black is already done. We could have 8 and white, or we could have 8 and silver. So we'll look at the 16s now. So 16 with a black colour, 16 memory with a white colour, or a 16 memory with a silver colour. Now finally, we could have a 32 memory with a black colour, a 32 memory with a white colour, or a 32 memory with a silver colour. So that's all of the different options. Now, each phone also comes in 2 different screen sizes. Find out how many options Jerry could choose from his phone, taking into account memory, size, colour and screen size. Okay, so for memory, how many different options do we have? We have 3 different options, so there's 8, 16 or 32. For colour, we also had 3 different options, so black, white or silver. That was 3 options. And then now they're saying that we can also pick screen size. And it comes in 2 different sizes. So the total number of possible combinations that Jerry could choose from is going to be 3 by 3 by 2. You can put that straight into the calculator and you will get 18 different options. that's the end of that question. It is. So now we're moving to 2018, paper 2. Okay, so question 6. Harrier plays a chess competition. In each game, she can win, which stands for W, draw, we've got the letter D, or lose, L. So fill in the table below to show the 9 possible outcomes for Hager's first 2 games. The two are already done. So LW means that she lost game 1 and won game 2. Okay, so you're basically, the first option there would be W. So I'm looking at this and this together. Then, so W and W would mean that she'd win both. Then I'd look win and draw, so WD, and then finally win and L, so win and lose. So there are the 3 options there. So then if we look at the next one, so draw and win will be the next, so draw and win. 2 draws is done for you already. Draw and lose, so draw and lose is going to be there. And then finally, L and W is done. So L and W is done. L and D, which is lose or draw, or lose and draw, sorry. And then finally lose and lose, so you lose both games. So that's that one done. So Hager plays 3 games in the competition. Work out the total number of different possible outcomes for her 3 games. Okay, so we need to work out the total number of possible outcomes for all 3 games that she plays. Now there are 9 possible outcomes, as you can see from the table above. So there's going to be 9 possible outcomes, and she plays 3 games in the competition. So it's going to be 9 by 3, and that's going to be 27. So 27 possible outcomes. Okay, and that's actually the end of that question as well. So we'll go on to the next one. So the next one is 2014, paper 2. So the following terms can be used to describe the probability that an event happens. So you've likely, certain, unlikely, impossible, or 50-50. So for each event in the table below, use one of the terms to describe the probability that it happens. So when a fair coin is tossed, you get a head. Now that is a 50-50 chance of happening. So that is going to be 50-50. If you buy a lottery ticket for next Saturday's draw, you will win the jackpot. Now that is unlikely because the chances of winning the lotto is unlikely anyway, but the chances of winning a lottery ticket for next Saturday's draw is very specific, so it's going to be unlikely for that one, unfortunately. And then the 1st of January will be New Year's Day. Now that is certain. Always the 1st of January is always New Year's Day, so certain is going to go into that box. Okay, we're on to part B. 4 events are listed below. So A, you pick a red ball from a bag containing 3 black and 7 red balls. B, you get a natural number less than 7 when you roll a regular 6-sided die. C, you pick a red card from a deck of playing cards. D, you pick a yellow ball from a bag containing 4 red balls and 2 white balls. Okay. Write each of the letters A, B, C and D into the correct box on the probability scale below to show the probability of each event. Okay, so first of all, if we look at event A, so you pick a red ball from a bag containing 3 black and 7 red balls. Okay, so if we have 7 red balls and you pick a red ball, so it's going to be 7 out of 10 chance because there's 10 balls in total, so 3 plus 7 is 10, so a 7 in 10 chance. So for A, a 7 in 10 chance, that would be roughly here for A. If we look at B, you get a natural number less than 7 when you roll a regular 6-sided die. Well, that is going to be certain because the numbers on a 6-sided die are 1, 2, 3, 4, 5 and 6, and they are all natural numbers less than 7, so that is certain. So we're going to put event B in the certain scale. So remember, 1 is certain, 0.5 is 50-50 and 0 is impossible. So let's look at C. You pick a red card from a deck of playing cards. Now half the cards in a packet of playing cards are red and the other half are black, so that's a 1 in 2 chance. So it's 50-50, so we're going to put event C here, bang slam in the middle. And then finally D, there's only one option for D, but we're going to look through it anyway. You pick a yellow ball from a bag containing 4 red balls and 2 white balls, but there's no yellow balls there at all, so that's going to be a 0 chance. So we're going to put event D at the impossible. So I'm just going to label these as well. So this is impossible. And in the middle we have a 50-50 chance. And then 1 means certain. So try and keep that in your mind as well. And I think that's the end of that question as well. So I think we have one more question to do. So I'm going to put that down now. I'm going to scroll down. We're going to go to one more question. So I'm going to scroll down here now to the last question. So 2013 paper 2, question 3. So a hurling match is played between team A and team B. A player on team A, Fiacra, has the ball and attempts to score. The probability of Fiacra scoring a point is 0.6 and the probability of him scoring a goal is 0.1. So again, I'm just going to write this alongside. So the probability of scoring a point is 0.6 and the probability of scoring a goal is 0.1. Now you're being asked there, is Fiacra more likely to score a point or a goal? Well, which one is higher? So a point is 0.6, so he's more likely to score a point because a goal is only 0.1. So the answer there is he's more likely to score a point. So for part B, what is the probability that Fiacra will not score a point in this attempt? Now, for a question like this, we always consider the probability that he will score, the probability that he won't score a point, you take it away from 1, okay? So we know that the probability of him scoring a point is going to be 0.6. We've been told that. So the probability of him not scoring a point is actually going to be 1 minus 0.6. And 1 minus 0.6 gives us 0.4. And if you put that into the calculator, you might get 2/5 either. So either of those answers will be accepted there. And then a player on team B, Pather, has the ball and attempts to score. The probability of Pather scoring a point is 0.7 and the probability of him scoring a goal is 0.2. So again, let's just write this out. So the probability of Pather scoring a point is 0.7 and the probability of him scoring a goal is 0.2. So Pather is more likely to score than Fiacra. Give a reason why this is true. Okay, well the probability of Pather scoring a point is 0.7 and the probability of Fiacra scoring a point is 0.6. That's what was given to us. The probability of Pather scoring a goal is 0.2 and the probability of Fiacra scoring a goal is 0.1, I think. Yeah, 0.1. Now, if we look at both of these, for the point system, so 0.7 is obviously greater than 0.6. So Pather has a greater chance of scoring a point than Fiacra when we're talking about points directly. If we look at goals, 0.2 is greater than 0.1. So again, Pather has a greater chance of scoring a goal than Fiacra because his probability is higher. And that's fine, just to write what I've written there, that explains your answer. And it's true. I'll just write that aside as well, that it is true. So Pather is more likely to score than Fiacra. So for part D, a spectator says Pather will always score more than Fiacra in a game between the two teams. Do you agree with the spectator? Now, the answer here is actually, it should be no. And the reason being that, the probability of Pather scoring, it is higher, but it doesn't mean that he will score or score more in any particular game. So we need to just write that in a sentence. So while the probability of pattern scoring is higher, so while the probability of pattern scoring is higher, it does not mean that he will score or score more in any particular game. So it doesn't mean that he'll always score more just because he has a higher probability. So the last part of the question here, a penalty is awarded to Team B. The goalkeeper for Team A has saved 12 penalties out of 20 this season. What is the probability that the goalkeeper will save the penalty based on his previous record? Okay, so you're completely basing this on his previous record. So out of a total of 20 penalties, this particular goalkeeper has managed to save 12. So that's his probability of saving another penalty. So can we shorten down 12 over 20? Well, 4 will go into both of them. 4 goes into 12 3 times and 4 goes into 20 5 times. Now if you wanted to put that into the calculator reader, it's going to be 0.6. So that's it. I'm going to attach some extra links and videos as well, which I recommend that you follow. And make sure and go back over the theory that I covered at the start of the lesson as well. And I will chat to you next week.